Welcome. We had enough discussions on time varying field and Maxwell's equations. So, from this video, we will be discussing something more interesting, that is waves. To be specific, electromagnetic waves. The electromagnetic waves are said to exist if Maxwell's equations are satisfied everywhere in the space where we are considering this electromagnetic wave. Yeah, don't worry. If you did not get my point, come to that later. I just told that here because to get a connection between what we have discussed in the previous video to carry forward to this particular video. Notice Maxwell's equations. We have studied Maxwell's equation. I have stressed what is the physical significance of Maxwell's equation, or what is the importance of remembering the mathematical equations of Maxwell. These mathematical equations will be used in a significant way to understand what are electromagnetic waves. So, when I say wave, what comes to your mind? Yeah, for most of our mind, if you are near to coastal city, or if you have watched enough Bollywood drama movies, a wave is a sea wave or an ocean wave for us. The moment I say wave, a beach side comes to your mind. A beach comes to your mind, isn't it? I hope majority will agree with me. Nothing wrong. Here too, to understand the wave, I would recommend you to imagine that you are on a beach side. Nice. During a sunset time, even nice. Should feel better now. So you can see water, right, forming waves when it is coming near to the shore. I will not get into scientific reasons of that particular wave, but you know that it is basically the pressure difference which is creating that wave. You will not find wave deep into the sea. Even when you stay or stand beachside, and if you look deep into the sea with your naked eyes, you can never see waves, right, at far from you, like maybe 100 meter or so, right? So these waves, when the water approaches or when the water is near the beach, it forms these waves due to the pressure difference basically. We will not look into all the reasons. Yeah, why I am putting this forward? Putting this forward because you should have the feeling that we are going to study, or we are going to develop significance both physically and mathematically, how such kind of wave is generated and how behavior of such particular wave can be understood or studied. So for us, waves are basically means of transferring energy or information from one point to another point, or we say waves are means of transferring information from source to destination. So a point where, if there is a point where the wave starts is source, and if there is a point where this wave ends, then that particular point can be termed as destination. So this is directly taken from basic English, okay, source and destination. And now you understood how a wave will look like, because, yeah, right, and you understood that we are going to take up Maxwell's equation in its mathematical form and use it to explain something related to wave. These 2 points are very clear by now. Okay, now look at the figure what I have on my screen. Yeah, I know you were staring at that figure for some time now and I did not talk about it. There's nothing much to talk about it because that figure itself is speaking to you already. I just want to convey you that the visibility is due to light waves and the audibility is due to sound waves. It's not necessary for you to understand in deep what I mean, but when you are looking at the screen, you are able to see many things on the screen, different colors, what is written there. All these things are in your perception, in the sense all these things are as an image in your brain. That's why you are able to see that. So actually it is light. Okay, you are not agreeing. Okay, you switch off. Okay, you sit in a dark room, put on the lights and view the screen. Switch off the light. Okay, view the screen. Yeah, you can still view the screen. Why? Because the screen itself is providing you the light required for viewing that particular information. In contrast, you are reading something in a dark room, you have a book in your hand and suddenly the power goes off. Okay, can you read it? No, you have visibility. You will run around like in some comedy movies that you lost your visibility. Oh, I am blind. Because you know, okay, even though you know that you know it, back of your mind, it's known to you that it is a light. A light is required to see the things around us. So basically, as an electromagnetic engineer, I will tell that light waves are responsible for visibility. Now you have to agree with these examples. Same way, I would put forward that sound waves are necessary for audibility. That's why, even though your capacity or your audibility is very good, if there is some obstacle between the source of sound and the place you are sitting, even though the sound is very near, the source is like 10 meter, 20 meter to you, but you have so many obstacles in between, you will not be able to hear that sound properly. That is because these waves, sound waves generated from the source, is not able to travel up to your eardrum. So it is starting from the source, but it is getting stuck in between somewhere, or it is obstructed somewhere. It is not able to travel towards you, it is traveling somewhere else. Yeah, keeping these two in mind, okay, I am just trying to give you some physical perspective of these waves. Okay, nothing else. So I would say that light waves help us to see things and sound waves help us to hear things. That is nice. And I have used an electronic gadget, or I have used a smartphone to explain to you in this figure, because most of us are now smartphones are now our owners. They own us, right? No, not OWN. They own us. A smartphone owns us. So that's why I have used smartphone here. Okay, now just to make this interesting. So I hope now the things are getting more clear to you. What is the physical significance of waves in our day-to-day life? It is not just enjoying a sunset evening in the beach. waves are everywhere around you, in you, and we don't realize it until we think about it, we study about it. So today in this video is the right time to study more about waves, because you are now eager to know more about waves. So the definition of a wave can be put it something like this. A wave is a physical phenomenon that occurs at one place at a given time and is reproduced at some other place at a later time. If there is a physical phenomenon something like this, then that physical phenomenon can be called as a wave. This is the basic definition, I would say. To understand this basic definition, I can go with one more physical example. Okay, I'll run through that example. You want to see ponds, right? Water body, pond, which is having a still water. You were enjoying that still water as well. But if somebody comes or you yourself felt very bored, right, on the side of a pond, you just took a stone from there and you pelted a stone to the river, to the water body, that is to the pond. What happens? Few of us might have done this, right? Few might have done this. So you put a stone, you pelt a stone into the still water body. What is generated? From nowhere, ripples are generated, right? That water body was still. Nobody would have expected a second back or a moment back that this still water body has some energy in it to produce such kind of ripples. If you pelt a very big stone into this still water body, it will form more higher ripples, more faster ripples. The water body, once disturbed, will produce these ripples. What are these ripples? These ripples are nothing but waves. If you are successful in pelting this stone to the center of the pond, these water ripples will form, right? It will start from the point of contact of the stone and it will distribute themselves to the sides of the pond. Nice. So basically, what does it tell you? It's energy. What does it tell you? It's basically kinetic energy. It was having some potential energy. Now that pelting of the stone converted that energy into kinetic energy. So basically an energy transfer is taking place there. That's why initially in the beginning of this video I told you that waves are the means of transferring energy from one point to another point. Now is that point very clear? So, I'll repeat the definition. A wave is a physical phenomenon that occurs at one place at a given time and reproduce at other place at a later time is best available definition. That's why I have taken the definition. There are many other definitions. And with this, you have to remember one more. I'll make it. Now we were very abstract, we were very general. Now we have to slowly take this concept of waves deep into our subject. Doing so, I would say that a wave is a function of time and space. I repeat, I say that wave is a function of time and space. That means, what does it mean? If you want to visualize a wave or if you want to study the behavior of a wave, both space and time is to be calculated, is required. I'll take the same example of producing a ripple in still water. You pelt the stone, you put the stone there at that particular time, maybe 10 a.m., 3 seconds. You pelted the stone. 10 a.m., 5 seconds. 10 a.m., 10 seconds. Maybe next 20 seconds that ripples will be there in that still water. Agree? And where will be that ripples? Will that ripples still at the source? No. As the time passes by, these ripples travels, right? It travels from the point of contact of the stone to the sides of the pond. So it is traveling. Where it is traveling? It is traveling in the pond, space. So it is consuming space from the center of the pond to the sides of the pond. It is consuming the space as well as it is consuming time. This doesn't happen at single time, at that time, at instantaneous time. It doesn't happen instantaneously. It happens time by time. At 0 second, if you pelt the stone, after 2 seconds, start forming ripples. At 5 seconds, the ripples almost reach half the way. After 10 seconds or 20 seconds, these ripples are going to reach the sides of the still body, water body. I hope this is very clear now. So any wave created at the source will be a function of time and space. So other typical examples of electromagnetic waves you can take as TV signals. You watch television daily, on a daily basis, right? Most of us are TV goers, we watch TV. So the TV signals, whichever we are getting, or the radio waves, if you are listening to FM, frequency modulated waves, these are different examples of waves. Okay, if you are thinking about our defense, radar beams, laser beams. So there are different ways of connecting whatever we have understood so far into the real world. So the purpose of this video was just to give you a feeling that most of the physical activities or physical senses which we practice in our day-to-day life are part of successful functioning of waves, or waves are involved in most of our day-to-day senses or activities. Till this point of time, or till you watch this video, you are not aware of it, or maybe few of you were aware but we don't think much about it. Now this is the right time to think deep into wave, understand the physical significance of wave, and how we can make use of the interdependency equations given by Maxwell in deriving or in expressing these waves in a useful mathematical form. So we'll discuss about that in next video. Bye.